Good morning students. Welcome to the computer graphics class. In the previous class we have discussed about the overview of graphic system. Okay. Today we have discussed about raster scan display. So let us display in details. In this class we have discussed about the concept of raster scan display, working principle of raster scan display, and the applications and advantages and disadvantages of the raster scan display. Raster scan display. So first of all we know that what is raster. A rectangular array of points or dots is known as raster. Okay. An image is subdivided into a sequence of scan lines, which is scan lines which is horizontally or vertically, which can be further divided into discrete pixels for processing in a computer system. That means in the computer screen, the sequence of dots or sequence of scan lines horizontally is known as scan lines. Okay. A raster image is a collection of dots called pixel. So this one is so in this diagram. Okay. This is one example of the raster image. This one is the actual image, and when we enlarge this image, it can display in a pixel form. Okay. And this is your raster scan display. In this diagram, this one is your connector, and next is your electron gun, and this is your control electrode, and next one is your focusing electrode. The next plate is your horizontal deflection, and next one is your vertical deflection. And these lines are known as the scan lines, and this one, the dotted lines which is displayed here is your horizontal details, and the line which is diagonally displayed here from top to bottom, this one is your vertical details. Okay. And the line which is focuses on the monitor screen or phosphorus coated screen is your electron beam. So let us discuss in detail how it is working. In the architecture of raster scan display, it consists of display controller, CPU, video controller, refresh buffer, keyboard, mouse, and CRT. So next we discuss about the working principle of raster scan display. The display image is stored in the form of binary, which is your 1 and 0 form, and it is stored in the refresh buffer. Okay. The video controller reads this refresh buffer and produces the actual image on the screen. It will scan one line at a time. Okay. From top to bottom and then back to the top. In this method, the horizontal and vertical deflection signals are generated to move the beam all over the screen in a pattern shown in the next figure. In this figure, here the beam is swept back and forth from the left to the right. That means when we scan one line at a time, it can scan the one lines from left to right. After that, it will at that time when it will scan the one line, it is that means it is on. Okay. And when after that it is off, again it will start from the left to right. In this way, it will scan the lines one by one at a time. Okay. And these dotted lines are known as horizontal details. When it will scan all the lines, again it will move from bottom to top and scan next line and one by one. And when it is moved from bottom to top, the line which is shown here is a dotted line. This is known as your vertical details. Okay. Yes. When the beam is moved from the left to right, it is on. When beam is moved from right to left, it is off. Okay. And the processing of moving beam from right to left after completion of row is known as horizontal retrace. Okay. When beam is reached at the bottom of the screen, it is made off and rapidly retraced back to the top left to start again, and process of moving back to top is known as your vertical retrace. The screen image is maintained by repeatedly scanning the same image. This process is known as your refreshing of screen. In this figure, it will draw a triangle, but here it will display how it will scan the lines one by one, and the point which is the point or the dots, which is the pixel, which is here positioning. In this way it will that means in the first line it will only the triangle stop pixel only here display. Okay, one by one it will in the every line the dots with the dots or pixel which will be pointing on the screen or which will be positioning or drawing on the screen, that will be only scan, and rest of the again starts from the first, then second line will be pointed. Okay, in this way it will draw the triangle. In raster scan display, a special area of memory is dedicated to graphics only. This memory is called the frame buffer. Frame buffer holds the set of intensity values for all the screen points. Okay, that intensity is retrieved from the frame buffer and displayed on the screen one row at a time. Each screen point is referred as pixel or pel. That means pel means picture element. Okay. Each pixel can be specified by its row and column numbers. It can be simply black and white system to color system. Okay. In simple black and white system, each pixel is either on or off. So only one bit per pixel is needed. Okay. Additional bits are required when color and intensity variations can be displayed. Up to 24 bits per pixel are included in high quality display system. On a black and white system with 1 bit per pixel, the frame buffer is commonly called a bitmap. And for the system with multiple bits per pixel, the frame buffer is often referred to as pixel map or pixmap. Okay. Next one is your types of scanning. How to in the raster scan system or raster scan display, the beam is traveling. The beam is traveling in two methods. One is your interlaced scanning, second one is your non-interlaced scanning. Let us discuss one by one. First one is your interlacing or interlaced scanning. In interlaced scanning, each horizontal line of the screen is traced from top to bottom. Okay. Due to which fading of display of object may occur, this problem can be solved by non-interlaced scanning. Every full screen of information is made up of two separate fields which include the odd field and even field. That means here it will first scan the odd lines, then it will scan the even lines. Okay. First the odd lines are printed on the graphic screen, then the even lines are printed between the odd lines before the odd lines fade out. Okay. Or fade out. For interlaced display, refresh rate of for interlaced display refresh rate of 60 frames per second is used. Okay. So in this diagram, it will show you for the actual image is this one, but when it is scanned, first odd lines are scanning, then even lines are scanned. Okay. When we merge this odd line and even line, we will get the full picture or complete image. Okay. Let us discuss non-interlacing. A non-interlaced scanning or progressive scanning does the whole job in one pass, tracing each row consecutively. In progressive scan, the displaying video speed is quicker than interlaced scan. Okay. In progressive scan or the non-interlacing, the video quality is superior than non-interlaced scan, and there is not present combining effect in progressive scan. Okay. For non-interlaced display, refresh rate is 30 frames per second. And what it gives figure. But in interlace scanning, the refresh rate is 60 frames per second. Okay. So here one term is here. This one is your flicker. What is flicker? A perceptible change in light intensity, generally caused by a small fluctuation in voltage. Okay. Rarely harmful to electronic equipment and causing the annoying and noticeable change in lighting levels. Okay. This is your flicker. This one is your diagram. One is interlaced and another one is your non-interlaced. Okay. In interlaced, that means first odd lines are scanned, then even lines are scanned. After, when we merge this odd line and even line, we will get the complete picture. But in non-interlaced scanning, it will scan at a time even and odd both lines. Okay. Next one is your concept is your resolution aspect ratio. So first we discuss about the resolution. Resolution is used to describe the number of pixels that are used on display image, and the aspect ratio is the ratio of width of its height and height. Its measuring unit is in length and number of pixels. The aspect ratio is the ratio of the number of x pixel to the number of y pixel. That means horizontal and vertical. Okay. The standard aspect ratio for PC is 4:3. And some common resolution, the respective number of pixel and standard aspect ratio are given below. When the resolution is 320 into 240, that means the number of pixel is 76800 and the aspect ratio is 4:3. So in this way, when the resolution is 640 into 480, then the number of pixel is 30,7200, and in this way, when the resolution is 800 into 600, the number of pixel is 480,000. Okay, so in this way, all these different types of resolutions are there and number of pixels are there. At this, according to this resolution, aspect ratio is given. Okay. Next one is your application, where the raster scan display is used. It is suitable for realistic display of screen. Home television, computer printers create their image basically by raster scanning. Laser printers use a spinning polygonal mirror and to scan across the photosensitive drop and paper movement, provide the other scan axis. Okay. In these laser printers, raster scan display also used, and common raster image format are your .bmp, .jpeg, .gif, .png and .psd. PNG means portable network graphics, PSD means Adobe Photoshop. Okay. And BMP, JPEG, GIF, all of you know this. Next is your advantages of raster scan display. The advantages are computer monitors and TV use this method and it gives the realistic image. Million different colors to be used or generated, and shadow scenes are also possible here. High degree realism is achieved in picture, advanced shading and hidden surface technique. So these are the advantages of raster scan. And next one is your disadvantages. Line produced are zigzag as the plotted values are discrete, and resolution is low and it is very expensive. Okay. So thank you in this class. In the next class we have discussed next topic.